Assalamualaikum warahmatullahi wabarakatuh. Our group will be presenting our power electronics assignment titled Sport Utility Vehicle SUV. These are our team members, Dayini Basyirah, me, Aneesa Irdina, and ZUHAIRAH. These are our agenda for this assignment.
The assignment is about the conversion of a full power SUV to an electric vehicle using modern power electronic converters and isolation devices within a 800,000 ringgit budget. The main power electronic components involved are AC to DC rectifier, DC to DC choppers, and DC to AC inverters, which all of these are critical for efficient energy management in EVs. SUV, which is Sport Utility Vehicle, is a general term that typically refers to a variety of vehicle with four-wheel drive that can be driven off-road and have the feeling more of a lighter truck. For example, Range Rover, Chevrolet Suburban, and Jeep-style SUVs. AC to DC, DC to DC, and DC to AC converters allow for seamless energy conversion and distribution throughout the vehicle. This technology ensures that the excellent running of the electric motors, allowing the SUV to achieve peak performance and torque. They also allow for compatibility with charging infrastructure, making battery charging more efficient. This power electronic system improved the SUV overall economy, range, and driving experience by successfully regulating power consumption and making the converted EV a sustainable and practical choice for SUV users.
Next is the problem background. The automotive industry is transforming to embrace sustainability and environmentally friendly transportation. SUVs are a significant contributors to greenhouse gas emissions, pushing automakers and policymakers to explore electric vehicles, EVs, as a solution. EVs offer environmental and economic benefits such as reduced emissions, lower operating costs, and decreased reliance on finite resources. Transitioning from internal combustion engine vehicles to EVs poses technical challenges, particularly in power electronics. Power electronics are vital for EV functionality, including AC to DC converters, DC to DC converters, DC to AC converters, and power electronic isolation systems. These components are essential for efficient energy conversion, management, and distribution, ensuring the vehicle optimal performance and safety. So the focus is on developing a comprehensive power electronic system for converting traditional fuel-based SUVs to an electric vehicles. So the key challenges includes efficient energy conversion, developing highly efficient converters to minimize energy losses and maximize the driving range of converted electric SUVs. Next is voltage regulation and distribution, designing DC to DC converters to ensure stable voltage levels for different components. And next is safety and isolation, implementing robust isolation systems to protect against electrical faults and ensure passenger safety. And next is system integration, ensuring seamless integration of power electronics with the existing vehicle architecture and electrical systems.
For SUV cars, they use two converters, which is inverter and DC to DC converter. In inverter actually change the voltage from DC to AC of an electrical power source. In hybrid or electric SUV, they convert DC from the battery into AC for the electric motors. It can handle higher power levels due to larger and more powerful motors needed for the heavier vehicle. For DC to DC converters, uh, the SUV actually focus on buck converters, which specifically intended to step down high voltage to a smaller voltage. It is to power auxiliary system from the primary battery and ensure that auxiliary system such as lights, entertainment, heating, ventilation, and air conditioner receive sufficient electrical power by converting the high voltage from the battery pack to a suitable lower voltage, often around 12 volts. This is the working principle of inverter. The left side of the slide shows that the block diagram illustrates the key component of a DC to AC converters. Number one, input filter. Then we go through the inverter and then output filter. At the right side of the slide shows the inverter block diagram from how DC convert to AC. First, we move to the DC power input and then the switching circuit. In the switching stage, the straight DC signal is chopped by a group of power switches, which is transistors. By turning the power on and off for a specific duration, a DC signal gets chopped just the right way to form modified square wave, as shown in the figure below. And then we move to the step-up transformer. In this step-up transformer, due to load requirements, the inverter must boost the voltage of this wave. And then we move to the smooth turning circuit. Once boosted, the inverter uses various filters to smoothen the sharp edges on the modified square wave to produce usable AC power. And then we get the AC power output. This is the working principle of DC to DC converter, or to be exact, the buck converters. Um, the left side, the left figure shows the diagram of buck converters when it is on state. How it works? If the switch is closed, current flows through it into the circuit. As the current increases, the magnetic field of the inductor increases. While that situation happens, the inductor stores energy in its magnetic field. Beforehand, the inductor's polarity will be positive on the left and negative on the right. This opposing voltage minimizes the voltage from the source, thus lowering the net voltage across the load. While the right side of the right figures of the slide shows the diagram of buck converters when it is off state. When we open the switch, the magnetic field of the inductor breaks down and current flows from the inductor to the diode. This current will be added to the current flowing during the first phase, which is the off state situation. That is why the average current on this sort of converter increases. This also adjusts for the lower voltage and maintaining the power supplied to the load.
Next is literature review, AC to DC converters for SUVs. AC to DC converters, also known as rectifiers, convert grid AC to DC for battery charging. Wide bandgap semiconductors like silicon carbide and gallium nitride have improved efficiency and power density of these converters. It is crucial for high power SUVs. Multi-phase interleaved converters reduce current ripple and enhance thermal performance for SUV applications. For DC to DC converters for SUVs, DC to DC converters manage voltage levels for SUV components like battery, motor, and auxiliaries. Isolated DC to DC converters allow high voltage batteries to safely interface with low voltage systems in SUVs. Resonant or quasi-resonant topologies and advanced control improve efficiency by reducing switching losses. Next, DC to AC converters, or also known as inverters for SUVs. Inverters convert DC power, battery power to AC for electric motors. Modern inverters use SVPWM to optimize switching and reduce harmonics, important for high power SUVs. Wide bandgap semiconductors like silicon carbide and gallium nitride enhance inverter efficiency and thermal management. For power electronic isolation systems for SUVs, isolation systems prevent high voltage from reaching vehicle chassis and low voltage components. Magnetic and capacitive isolation techniques are commonly used, with planar transformers and integrated magnetics offering compact and high performance solutions. Advancements in insulation materials and manufacturing improve isolation system durability and thermal stability.
Electronic design. As we know, in automotive, electrical and electronic cars, we include application of power electronic. First, in SUV car, we have automotive power generation. It is automotive power generation system provide automotive alternatives with improved efficiency and high power, along with high temperature withstanding capacity and high power density. Next is a switch mode power supply, also known as SMPS. This concept is based on power electronic devices, including semiconductors, which have the potential to operate at 100 efficiency in both on and off states with zero voltage and current. These power semiconductor devices are turned on and off by path with modulation or PWM. Next is onboard charger ACDC. As we know, in cars with automatic electronics need to charge their batteries, right? So which necessity converting the AC power supply into DC. As far as we know, batteries can only store direct current DC. So this AC power may be converted to DC using rectifier, also known as electronic converters. Next is DC to DC converter. This is also called as long-lasting, soft-switching, and incredibly dependable converters that are incredibly helpful in the car electronic industry. It's as bidirectional converters are available, such as those that convert 400 to 12 volt for electric cars and 48 to 12 volt for internal combustion engine. We call it as hybrid electric cars. And next is traction inverter, DC AC. Okay, this is use of power electronic in switching has brought the concept of source switching, in which switch are subjected to little stress using LLC or resonant mode. Yeah, so in this automobile electronic business, these so durable, source switching and highly reliable converters are available. Next, we move to cost. Cost, I have divided into five parts, which are additional expenses, power electronic components, material costs, labor costs, and manufacturing process. Advancement of power electronic used in SUV car. First is so high operating temperature capabilities. Is function as reliably under harsh condition, assures performance stability. Second is it can enhance system efficiency. So overall efficiency in automotive electrical system led to more efficient vehicles and optimizing energy conversion process. Third is size reduction and weight saving. This lead to miniaturization of electronic circuit, which is it can improve in packaging density and space utilization, resulting in more compact and efficient automotive system. The fourth one is it can improve reliability, which is this robust power electronics design. It can focus on minimizing failure rates and downtime. This it also can improving overall reliability in automotive applications. The last one is it can increase flexibility. This the SUV design it can to adapt it it could adapt to diverse vehicle architecture and requirements, and also can enhancing system versatility and functionality. Is can check the process of to be SUV car. It takes 72 months, equal to 6 years.
For the conclusions, These vehicles can achieve longer range and improve performance while using less energy by optimizing energy conversion and enhancing system efficiency. The capacity of power electronics component to withstand high temperature provides consistent functioning in adverse conditions, increasing the durability of electric SUVs. Power electronics play a crucial role in advancing electric SUVs and making them more sustainable, efficient, and beneficial for society and the economy.